Hello everyone, my name is Numair Qureshi and I want to welcome you to Unfolding Destiny, where we teach you how to build your life within the context of your own identity. So today, we're going to talk about how Einstein's relativity opened up the doors to the quantum universe. So what does this have to do with consciousness and identity? Well, you have to realize that your identity, the very aspect of who you are, is part of this greater cosmic whole. And to better understand yourself, you have to understand how the universe operates. So today, we're not going to delve deeply into quantum mechanics, I promise you. But what I do want to do is I want to set the stage for how relativity opened up that door so that you can better understand yourself and the cosmos. So let's talk about Isaac Newton first. So Newton came up with these laws of motion. The first one being inertia, which is an object at rest likes to stay at rest, and an object at motion likes to stay at motion unless acted upon by an external force. The second law is force equals mass times acceleration, where force is inversely proportional to the size or the mass of an object and how fast it is going. The third is every action has an equal and opposite reaction. He was able to take these laws and apply them to the universal law of gravitation, which it looks like a complex equation, but all it really asserts is that every mass in the universe attracts every other mass in the universe. So basically, even this marker here has an attractive force on this mirror. The only reason why they don't come crashing into one another is because the mass of the Earth has the greatest gravitational force on us. So everything just kind of falls straight down. So in the Newtonian world, everything was calculable. It was time, it was space, there was the grid, and everything moved relative to one another. In the Newtonian world, when I talk about time, space, and grids, here's what I mean. You could have a clock here, you could have a clock over here, and they would have the exact same time regardless of where they were. And when you talk about motion, you apply these laws of motion in 1, 2, and 3, the first 3 laws. You could have anything moving from point A to point B on the grid, and you can calculate its trajectory and its momentum in absolute time. And the reason why motion existed was, or the reason why you were able to calculate motion was because it was relative to other things. So something is moving relative to something that is stationary, and that's how you can discover motion, and that's how you can calculate it. So in the Newtonian world, everything was clockwork and predictable. And so let's move on to Michael Faraday, because as you go down the road of science, things become crazier and crazier. So Michael Faraday was a scientist who discovered electromagnetism. So he studied electricity and magnets and how they work together. I'm not going to go into his story, but it's pretty phenomenal. Having said that, he realized that physical light is electromagnetism, but he couldn't prove it. So he had to wait for James Maxwell to come along, and then Maxwell was able to prove it. What Maxwell discovered was that electricity and magnetism are woven together, as Michael Faraday had said. But you can't witness that until these are traveling at 670 miles per hour, which is light speed. Okay. So another thing that Maxwell discovered was that you cannot have static light. So now this is mind-boggling. Think about it this way. If this marker was going 50 miles an hour and you were running 50 miles per hour beside it and there was no other objects around you, motion would not exist. As a matter of fact, you too would seem like you're not moving at all because you're moving at the exact same speed, right? Now, of course, if the marker is going 50 miles an hour and you're going 5 miles an hour, then you would notice that the marker is passing you because you're moving relatively to one another, as indicated in the Newtonian world, on this grid-like system. In the Maxwellian world, things started to become a little crazy because Maxwell, as I mentioned, he discovered that you cannot have static light. Now, let's talk about Einstein. The Einsteinian world became even crazier. Einstein was obsessed with light. From a very young age, he was obsessed with figuring out what exactly light is. So, okay, Faraday discovers that physical light is electromagnetism, okay? Maxwell says that, well, electromagnetism is woven together. Electricity and magnetism operate together in this like incredible pattern where they're almost one and the same at the speed of light. But then Einstein's asking, well, what is light? And he spent a long time trying to tackle that question. He asked himself, what is it like to ride on a beam of light? As a matter of fact, if you were to walk up to light or run up to light and you're going at light speed, you're going at the same speed as light. Well, yeah, you're traveling at the speed of light to see a beam of light. What would happen? In the marker analogy, with my marker and I guess my finger here, if we're traveling at the same speed, well, the marker should stop, right? In your eyes, it should stop moving because you both are moving at the exact same speed. In this world, things are a little bit crazier. What would happen if you take light, which cannot be static in the Maxwellian world, and you're running up to it? Does it suddenly stop? Do you just see a shimmer and a flicker, and is it just beautiful? Or what happens? Well, if you take the Maxwellian point of view that no, light can never just stay still, there's no such thing as static light, then the universe becomes even crazier. What that means is that light is the absolute reference point of the universe. See, in Newton's world, there was the grid, and then everything moved according to that grid. Space and time, they were calculable in reference to a grid, and things were relative to one another. Motion was relative to other objects. In the Einsteinian world, it turned out that light was the absolute reference point of the universe. But in order for that to be true, it would mean that physics had to become even spookier. What that would mean is that the very things that you thought were calculable suddenly became almost unpredictable. It would mean that energy and matter were interchangeable. Energy and matter could actually convert into one another in relation to light, but also energy, matter, and even time could slow down or speed up or warp in the presence of light. So what that means is, in order for light to be the absolute reference point of the universe, in order for it to keep its speed at 670 million miles per hour from point A to point B, it would mean that nothing could get in its way. But think about it this way. You take my finger, if it goes 10 miles an hour into a wall, my finger is going to break, right? It's going to slow down. If you take any object, it goes fast enough, but if there's something in its way, it's going to slow down. It's going to hit friction. Things are going to slow it down. But with light, it never slows down. So imagine light hitting this wall, boom, boom, bouncing off, but it never seems to slow down. How is that the case? How is it that gravity doesn't slow down light? Gravity's going to drop this pen. It's going to slow it down. If an asteroid comes down, eventually gravity is going to cause a lot of friction, and there's going to be a lot of heat, and then eventually the asteroid hits the ground and it slows down. But light just seems to bounce off of everywhere, and nothing seems to slow it down. The only way that light can keep its speed is if the universe warps around it. Meaning, the Newtonian world, where things are absolute everywhere, is no longer true. In the Einsteinian world, time becomes relative, space becomes relative. So he came up with the idea of space-time. In his world, you could have a clock over here, and you could have a clock over here, and they could be operating at different times. And he also realized that space itself warps around light. There's even the curvature of space, that he saw space as a fabric. And I'm not going to talk about the curvature of space and how things stay on celestial orbit. But what I will say is that I want you to understand that the very things that you think are physical and rigid now are more malleable than ever. That light is the absolute reference point of the universe. But this ended up opening up a whole new universe called the quantum universe. See, Einstein believed in predictability as well and causality, and he believed that things could be calculated, similar to how Newton's beliefs. Einstein, though, with his theory of relativity, he was able to open up the doors to the quantum universe, and in the quantum universe, crazier things happen. So think about it this way. if matter warps around light, if gravity warps around light, if physical objects warp around light, think about it this way. Imagine a building as strong and as rigid as it is. If you were to look at it in reference to light, just for light to be able to pass around it, the building would have to warp at some cosmic levels indetectable to the human eye. In order for that to happen, and what that means is that the universe is this crazy mess of warps and fabric, and it means that things are happening at such an interesting level that even though we can't see them with our eyes, the universe itself is bending, that time and space are warping around this light. And that gravity, the mass of an object, can affect how quickly or how slowly time moves. Suddenly, we're opening up a whole new can of worms. And what Einstein believed was that God does not play dice. And he tried for the rest of his life to disprove quantum mechanics. In the quantum world, an object could be here and an object could be here. And you cannot determine how it got from point A to point B. And I'm not going to get into that because that completely goes against the Newtonian model. In the Newtonian model, obviously, if this was here and it came here, and there's the possibility that it went through all these points to get to here. In the quantum world, with the curvature of time and space and how things can move and warp around light, what you're also starting to realize is that you can be here and you can be here, and there could be a million ways to have gotten there, and you can't even detect how the object got there. In the quantum world, what you can see is that you can detect a position, but you cannot necessarily detect how something got there. Or you can see the trajectory of something going somewhere, but that doesn't necessarily mean that you can know where exactly it will end up, because things are unpredictable at the quantum level. So what I wanted to do with this video was to kind of show you how unpredictable the universe is at the quantum level, just opening up the doors, because it's really important to realize that our mind is part and parcel of this cosmic whole, that we live in this unpredictable world where even where things at the surface level seem to be calculable, there's this whole other aspect to it. And I want to marry that belief with consciousness. I want you to realize that even the way that you grow throughout life, I mean, there's a metaphor here more than anything else, that there are aspects of yourself that you can detect, that you can observe, but there's other aspects of yourself that you still haven't come into contact with yet, the hidden aspects of yourself. And that you have to realize that you got to look within and you got to start looking at those patterns and realize that there's parts of yourself that are bigger than just what you see in the surface. And it's important to understand how science works and to integrate those belief systems into your own life so that you can become the best version of yourself and integrate yourself into your conscious whole. Now, in other videos, we're going to dive even more deeply into the quantum world. We're going to talk about psychology and consciousness, but we're going to stay scientific. We're going to stay humble because we don't know everything, and we can't say that one thing means another. All I can say is that there's these patterns that I see in the universe, and I want to do my best to see if we can somehow integrate them into a theory of self through these videos. All right, so if you liked what you saw, please like, comment, share. Share this with other people. Hit that notification bell. Sign up at unfoldingdestiny.com. Register, put your name and email in the boxes, and you'll get free stuff like the Rules of Legacy poster. Anyway, look, it's been a pleasure, and I hope to see you soon. Take care.